Okay, welcome to Chapter 6 in Hot Topics. We're just going to basically summarize radicals for you and help you out with those new radicals, that, the cubes and the force and everything else that you're seeing.
Yeah, again, I think these are relatively easy to conquer. So we're just going to look at a few problems. And I think if you can do these, you'll go back into Alex and you should be in good shape. All right, so let's start off with looking at problems involving square roots. And when we're looking at square roots, we want to have the perfect squares in our head. So I'm going to write these at the bottom. Perfect squares are 1, which won't help us much, but then 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, and 10 times 10. All right, so now if you grab your calculator and ask it what the square root of 40 is, it'll give you a decimal answer, but that's not the question that you're being asked to answer here. What you're being asked to do is simplify this radical, that is, rewrite it in a simpler form in the same way that we reduce fractions to lowest terms. And the way to do this is easy. We take a look at the 40. We see where it falls here. 40 would fall right here. It's between 36 and 49. And we look here at the first number on the list that divides evenly into 40. And that number is 4. So I think of 40 as 4 times 10. And the square root of 4 times 10, I'm allowed to break that up into the square root of 4 times the square root of 10. But I know the square root of 4, it's 2. 2 squared is 4, so the square root of 4 is 2. So this can just be written as 2 the square root of 10. And that's the answer that we're after. And this is considered simplified because now there is no number here that divides evenly into 10, whereas before there was a number in this list that divides into 40. Let's look at another example, and this example also contains a exponent, so we'll talk about how to deal with that. All right, so this time I have the number 27 under the radical. 27 would fall here. So I'm looking for the first number on this list that divides evenly into 27, and that number is 9. So I'll think of this as the square root of 9 times 3 times x to the 4th power. That's the square root of 9 times the square root of 3 times the square root of x to the 4th power. And I know the square root of 9, it's 3, and I also know the square root of x to the 4th power. If you have the square root of x raised to an even exponent, all you do is divide the exponent by 2 to get the answer. 4 divided by 2 is 2, so the square root of x to the 4th is x squared. I don't know the square root of 3, however, so it stays over here. So my answer is 3x squared, square root of 3.
So just remember, if you go back and you ask yourself, how is x squared equal to the square root of x to the 4th? Well, your rules of exponents, x squared times x squared, a number times itself, you add the power, so 2 plus 2 is 4. So
right, so again, this is a way to check to see why the square root of x to the 4th is x squared.
That's it.
All right, so let's look at a problem where the exponent is not an even number. There we have to do a little bit of rewriting. Again, if you look in the list, which I'll throw down here again really fast, 4, 9, 16, 25, 36, 49. I don't have to go any further because 50 would fall here. The number on this list that divides evenly into 50 is 25. So I rewrite 50 as 25 times 2. And if you have an odd exponent, what you do is you rewrite it in terms of the power that is 1 less. 7 minus 1 is 6. So I think of x to the 7th power as x to the 6th power times x to the 1st power. I do that because I know the square root of x to the 6th. It's the square root of x to the 7th that's a problem. And now I just break this up into 4 square roots. This is the square root of 25 times the square root of 2 times the square root of x to the 6th times the square root of x. Let's do the square roots we know first. I know the square root of 25, it's 5. I know the square root of x to the 6th. 6 divided by 2 gives me x cubed. But I don't know the square root of 2 or the square root of x, so those both stay under the radical sign. And this is our final answer, 5x cubed times the square root of 2x. All right, let's look at some problems involving cubes. For the problems involving cubes, we'd like to have a list of the perfect cubes. The perfect cubes are 1 times 1 times 1, 2 times 2 times 2, which is 8, 3 times 3 times 3, which is 27, then 64, then 125, then 216, 343, etc. I'm not going to go any further because the number here is 16, which falls right here. So the only number on my list, which is smaller than 16, is 8, and 8 actually divides into 16. All right, so we're going to go ahead and do this way. We're going to think of this as the cube root of 8 times 2 times x to the 5th. So this is the cube root of 8 times the cube root of 2 times the cube root of x to the 5th. All right, we'll do this in 2 steps. First, the cube root of 8 is 2, because 2 times 2 times 2 is 8. But I don't know the cube root of 2, so that's going to stay under the radical. Here, there are a couple ways to do this, but probably the easiest is just to do a little division. Divide the index 3 into this exponent 5. 3 goes into 5 once with a remainder of 2. This one gives you an x to the first power on the outside of the radical. This remainder gives you an x to the second power under the radical. So this number is the exponent that goes out here. This number is the exponent that goes under the radical. And this is the answer, 2x times the cube root of 2x squared.
Now, if you're wondering how we just did that, because you can't do it with numbers, but simply put, we're breaking down x to the 5th, the cube root of x to the 5th, into the cube root of x to the 3rd times the cube root of x squared. Many students have a problem breaking down radicals when we're dealing with powers. So we've learned through the years there's just a simple shortcut, which is that division rule.
Right.
So much easier. But Bill is showing you right now, this is exactly what we just did, but we did it in a much easier way. If we try to explain this and then tell you the next time you do it differently, normally it's just more confusing than what it's worth.
And the reality is that you're in a section or in a chapter now where you're doing quite a few of these problems. This is really the fastest way to probably do it. So if you understand how to make sense of this to get the answer, that's probably the fastest way to do it. And Jerry and I are all about the fastest, easiest way.
Yeah, Bill, actually go back and just point to them on the previous problem how that would have worked since
right,
there was not
that's
an
a good
index.
point, yes. So if we had wanted to do the other problem this way, the square root, the index is 2, so we could have done this and said 2 goes into 7 3 times with a remainder of 1. So this 3 is where this 3 comes from, and this 1 is where this 1 comes from. You could also have done that problem that way. That's a good point. Okay, let's look at the last two in this particular section. We're still dealing with cube roots here, and I'm not going to write out the list, but if you look at your list, 54 falls between 27 and 64, and the first number before 54, which is 27, actually divides into 54. So this one, I'm going to go ahead and rewrite as the cube root of 27 times 2 times x to the 9th. That is the cube root of 27 times the cube root of 2 times the cube root of x to the 9th. So first we'll do numbers. The cube root of 27 is 3. 3 times 3 times 3 is 27. We're going to have a cube root of 2 left over. And here, 3 divides into 9 3 times with a remainder of 0. So that gives me an x cubed out here, and there's no x here. So this is the final answer, 3x cubed times the cube root of 2.
And just watch the 2 3's next to each other. Every now and then students mix it up and think that the power on the x is also the the index, and that's not the case. And Alex, we know, will catch you on it.
Right. So yeah, so this is x cubed times the cube root of 2. Again, if I had neater handwriting, it'd be a little easier to see that. Let's do one problem involving fourth roots. For fourth roots, basically start listing the fourth roots until you come across a number that divides into 48. 1 times 1 times 1 times 1 is 1. That's not going to help you. But 2 times 2 times 2 times 2, that is 2 to the 4th power, is 16. And 16 does divide into 48. So
we call 16 a perfect fourth.
Right, this
root.
is a perfect 4th power, just like we talked about perfect squares and perfect cubes. All right, so let's go ahead and do the rest of it now. This is going to be the 4th root of 16 times 3 times x to the 20th power. That is the 4th root of 16 times the 4th root of 3 times the 4th root of x to the 20th power. I know the 4th root of 16, it's 2. I just figured that out down here. I don't know the 4th root of 3. I'll put that down. And here, again, we'll do our little division trick. 4 goes into 25 times with a remainder of 0. So this gives me an x to the 5th out here. Again, a little hard to read. That's 2x to the 5th times the 4th root of 3. That's the final answer. And if you need help on these are pretty much all of Chapter 6, I think.
Yeah, Chapter 6 covers all your radicals. Feel free to go back through it. Again, our examples are written out just the way we've shown them in here.
All right, and take care. We'll see you in the next Hot Topics.